Hello and welcome to another episode of Today You Learned. So today I want to talk to you about something else. This is already the third video in the advanced sniffing series, if you want to call it that. And this will be about something called coercing, or two different topics, coercing and downgrading. They do not really have anything to do with each other, but they go very well together if you pair them, and maybe even together with other stuff that you will learn prior to this or have learned prior to this and to come. So coercing, that's actually a fancy word for remotely forcing the authentication to our responder. That's a little bit the definition of coercing. So in the first two videos of this series, I actually manually forced the victim to authenticate or to send out signals that responder can respond to. Well, coercing is actually doing it without that, without the manual intervention, remotely with tools or options, services, getting or forcing the victim to authenticate to our responder, or to authenticate, send out broadcasts on the network so we can respond to them. The example that I want to use is actually a recent but very simple one. It's coercing authentication using something called the print spooler. This is actually a feature in Windows. It's in the Windows printer spool service, as you can see here. It's actually something that allows print system remote control via that port that you can see there. And sometimes it's called a bug, the print nightmare, also called the printer bug. But Microsoft actually says it's a feature, which means it has no CVE code. So it's not a bug, it's no CVE codes, and it's until today, up until the newest ones, it remains unpatched. So it's still vulnerable, if you want to call it so, the feature I want to use here. There are like 20 different ways of coercing. This is just an example. There are even some coercing methods that do not require authenticated credentials or authenticated users. In this case, for the print spool service, it works better with. Right? So it requires an authenticated user to connect to that vulnerable or that visible spool service, and it requests a binding. It's actually very similar in operation as it was to or was for the log4j vulnerability a couple of months ago, and it uses that binding to force Windows to connect to a given IP address, which we can specify, which then happens using the Windows machine account. So in other words, we will actually ask a Windows system to authenticate to my own IP address, which means that responder doesn't even have to respond to broadcast messages because there will not be any. It will be directly to my Kali machine, my hacking machine, and it will do so using the machine account because, of course, if you request it via an authenticated user, in our case David, for example, then we already get the hashes for David, so that's not very useful. But using the print spool service, we can actually perform something like an escalation of privileges, right? So it will actually respond with the hashes and authentication details of the machine, the operating system, and not the user. So if you want to verify, let's dive into this. So I will do a very short demonstration of this. If you want to verify if that spool service is running and reachable, available, this is a very easy way of doing that, or of verifying that. So let me go back to our environment right here. Remember, we have fully patched, fully up to date up until today, once again. Two domain controllers, a primary or a first and a second domain controller. This will be our victim for today. I will not even touch the Windows 11 if I'm not mistaken. As you can see, this is how the network is laid out. We can reach them all. The SMB is one for the second DC, and of course the Windows 11 is still active from the previous demo. So let's try out that scan for that vulnerability or that possibility to find if the print spooler is running. Let me do this right here. For example, this one. Again, this is a Python script built into Kali. It lists actually all the RPC services that are available on this IP address, and there are a lot, as you can see right here. And then if you want to know it specifically for our print system remote control system, the print spooler, if this is listed as it is right here, it means that the system is vulnerable for the print nightmare or the print spool issue, right? So coercing should work. Okay, that's okay. So how can we exploit that? How can we actually coerce with an authenticated user? There's a Windows tool called Spool Sample. There's actually printerbug.my from Dirk-Jan Mollema's shout out toolkit, Kerberos Relay X. The same one as NTLM Relay X script, or the easiest one, the one I will show you in a minute, is actually dementor.py. So actually I will show you that now. Dementor.py, it's a single Python script. Let's download that Python script like so, like this. So we have our Python script right here, and then you can see the options that it requires. So it requires a username, which we have from the previous demo, a password, which we have from the previous demo, a domain, which we have from here as well, demo22.lon, right? Then it needs the listener, which is our own IP address. Let's verify our own IP address just to be sure. 50.138, and then the target, which is of course the machine that we want to target. In this case, that would be the second domain controller, 76. Before I do this, because, well, actually, let's try it out. So it's trying that out right now. If I did not make any mistakes, it should work. It might take some time sometimes. So he will now, okay, so done. It worked, got expected. So the attack actually worked. However, I did not start my responder yet. So let's start the responder like we have done before. And maybe verbosity like this. And as you can see, it's the one from the last time. Well, before I continue here, I actually have to enable my captures because they were still disabled from the previous time. So let's maybe do that now. VI responder.conf. Let's enable those again, which is actually the default, right? The default settings would be this. So all the listeners or all the services are active like this. Okay, so now they're back on. Let's launch this one once again. It went a lot faster this time, and here we are. So what do we have? We have the print service from our Windows Server 2022 that requested an authentication via SMB, so Windows file shares, on the hacker environment. That's what happened here. And as you can see, it's for the user, or since we have a $sign here, it's actually a computer object. So computer, which is the host name right here, DCO2. This is the domain name, and then here we have the full NTLM v2 hash. Remember, this kind of hash, this NTLM v2 or v1 hash, is actually not usable. The only thing that we can do with this hash right now is try to crack it, right? Maybe we can try to relay it. I leave it up to you to try that out because I want to show you something a lot cooler. But cracking it is an option, although not a viable option, right? The machine account hashes are completely randomized or are extremely long, so it will take too much time and too long and too much effort to actually try to crack this. This is not crackable, right? Not brute forceable. So let's stop this even, and this is already stopped. So this is a good time to go to the second one, also only one slide, which is the downgrade attack. So let's downgrade. As you have seen, we now have an NTLM v2 hash. Let's downgrade that into an NTLM or net NTLM v1 hash, which has the upsides that we can do something special with it. Let's first explain this here. It's a downgrade attack, and for this we actually do need a custom setting. Well, a custom setting is actually the default setting. So we have the LAN manager authentication properties. This is actually a setting which by default in Windows Server 2019 and 2022 is secure, which is the bottom three one. These are secure. Any of the top three settings is not secure. Which will actually allow us to do what we will do in a minute, right? And when is this set to not secure? If the system actually has been updated from an older system. If, for example, it was installed as a server 2012 or 2016 even, and then updated to 19 or 2022, then this will probably still be in an unsecure setting. So if this is set to any of the three top settings right here, which means that LM authentication instead of NTLM authentication is an option, right? In this case, it would be optional, and in the other ones, it will even refuse NTLM, I believe, or it accepts them both at least. So if that is the case, responder will show us not NTLM v2 hashes, but v1 hashes, of which you can see an example right here. So this is again the username, then the domain, and if you look closely, this is actually the same as we see here. So we see 2 times the same hash, right? We have 7801 hash here, and then another one here, and then 4 is actually a challenge. So let's take a very quick closer look. These are 2 separate 8 bytes ECB crypts. So it's an encrypted hash that we see right here. 1 and 2 is an encrypted hash. And then the third section here is actually a checksum that we can use to start and calculate the last 2 bytes of the original NT hash. So the NT hash, the one that we can replay, that we can use for pass the hash, the NT hash is actually encrypted, encoded, maybe hashed, if you want to call it that, within numbers 1 and 2, sections 1 and 2. And the last 2 bytes are more or less clear text, which we can actually, if we have 1, 2, and 3, and we use this script in Kali, we can calculate at least the last 2 bytes. The last 4 characters would that be. Number 4 is then the random challenge, which is actually chosen by responder. If we go back to responder right here, you can see here that the challenge that is set is actually random, which would be, in this case, this little string right here, which is random. And we can see here that this is the random challenge that was selected by responder, which is the one that is used to actually encode or hash the separate scripts, right? So in other words, we can actually try to brute force the NT hash, because we can use these 2 DES ECB crypts to brute force the NT hash. There are a lot of tools to do this, or we can make it a lot simpler, and actually the challenge, the number 4 that we have here, and that's why I wanted to go into a little bit more depth. The number 4 here is actually under our control, so we can set that to a challenge that is known, a known factor. So in that case, it's a lot easier to crack them. We even have rainbow tables for that, which is pre-computed crackings or hashes that we can use to quickly determine the original NT hash with that same challenge. Everything is with the same challenge, and there's even a free website to do it on, crack.sh. So long story short, if we see this, and we have, of course, changed this to a known factor, you will see it in the next slide, then in 100% of the cases, we will be able to calculate or brute force using rainbow tables, so it would be a rainbow table attack, the original NT hash, right? Not the NTLM v1 hash, but the NT hash we can use to replay. Okay, what does this mean? It's actually very simple. The first half of the demo I actually already showed you. We will perform a coercion, and then we will force using the responder with the -LM option to actually remove the SSP option, go into an LM authentication. This will be the one that we want, and we will actually change that challenge to 1 1 2 2 3 3 4 4 5 and so on until we so that we can have a hash that we can crack on crack.sh, right? So in this case, the demo will actually not be for a user, but for the machine. If we have an NT hash or an NTLM hash, NT hash for a user, we can pass the hash. For a machine, that's not so simple. However, we can create a Kerberos silver ticket to create a silver ticket and then use that to get full access to the machine. Okay, it will be very cool. Let me show you. So actually very simple. 2 things I have to prepare. Maybe it's better to first do, all doesn't matter. So 2 things. First, I have to change the challenge not to be random anymore. That's the one. Should be 8 bytes, right? A byte is 2 characters. 8 bytes, like so. That sequence has not been, sorry, selected by me. It's by Crack, the website. The creator of the rainbow tables has used this one right here. Let's try it out. because it's easy to do. And as you can see, the hash is the salt, the challenge is no longer random. I can even do it 2 times, doesn't really matter that much, as you can see. So that's okay. However, we still have our NTLM v2 SSP. Let's maybe add this to the mix. So the downgrade attack. Now the SSP is gone, so we have a much shorter hash. In theory, this can also be tried to crack and hack, but it's not an NTLM v1, so we're not there yet. The reason it's not an NTLM v1 is because the setting, the Windows Server 22 setting, is, well, brand new, so it's not configured correctly. So let's pretend that this is an update from Windows Server 2012, 2016, something like that. For that, I need a command prompt, as administrator, preferably like this. This is the command. Actually, the 0 right here, 0, 1, and 2, is vulnerable. 4, 5, or 3, 4, 5 is not vulnerable. And I don't even have to reboot. Actually, it's already done. Let me coerce it once again, like so. And as you can see, we now have an NTLM v1 hash. And instead of being at the beginning, it's now at the end. So the hash that we actually want to crack, or the string that we need for our website, is this one. As you can see, like in the slides, it's 2 times the same. So it doesn't matter which one I pick, the first one or the second one. Let's copy that. Let's go to the website. This is the free website. You don't have to log in or anything. Do not have to create an account. If you go to get cracking, we can actually, so the parameter is nt hash column and then the hash from the website, from the Kali that was captured. We can enter any email address right here. Does not matter, right? Submit it for free. And in my earlier tests, it took 30 seconds to actually, we can monitor the state right here, but it took me 30 seconds to receive an email with the cracked hash. Let me show you. This is how the email address or the email looks like that you will receive for the exact hash that we just copy pasted, and this is then the NT hash that is behind it, right? Took 30 seconds. Okay, so this hash we can now abuse or reuse. We don't need this one anymore. So let's maybe first try if that hash actually does work. So just to verify if hashes are correctly. So let's see, this would be the machine that we just received the hash from. Okay, no, that's not correct. It would be the second one, so that's important, right? The user would be this one. Don't forget the $sign, of course. And then if I'm smart, I will copy paste the hash from the email. So like this. And if I'm smarter, do not make type errors like this. So capital H should be the hash, and a plus means that it is correct. The combination, because if I use a different hash, it will not be a plus. So this is a correct hash, which works. But as I said, it's not pwned. We cannot directly use pass the hash like this. But we can perform something called a pass the ticket, or create a ticket and then use that ticket. It will be something called a Kerberos ticket. In a different video, future video, I will try to explain that a little bit better or more. So to create that ticket, we actually need a couple of extra data, extra combinations. For example, we need something called the domain SID. So domain SID, you can do that with different tools, even unauthenticated, authenticated, doesn't really matter. This is the easiest tool. It's from Impacket, right? You might have heard of that. Look up SID, and then I just provide it with some credentials against that machine. So if I launch that, we actually get the domain SID right here. Right? Let's copy that. This is the domain SID, and you even get the full list of the users, including their SIDs, user IDs, or RIDs. These are actually RIDs, and then if you combine this with a dash and then the RID, you get the user SID and so on. Not important right now. So I have the domain SID, and now we can request a ticket. As we already have seen in other videos, there are a lot of options here, but to retrieve a ticket, we can use this one. Okay, so what do we need? The domain SID. which I just copy pasted. What do we also need? The NT hash of the machine that we want to use, or the account that we want to use. Of course, we have to specify the account itself, or the domain at least. The domain is important. Because Kerberos is actually built on top of DNS. So DNS is also important. Explain in a minute, or show in a minute, that will be required. What we also need for a ticket is something called the service principal name, SPN. In this case, we're interested in accessing Windows file shares. So that would be this one. On which machine? This machine, FQDN, so the full, yes, that's the one, the full host name of that machine, sys. And then we need the username. But it does not have to be a username that exists, because it's actually a machine account. So random user, whatever. Enter that. So it worked. It was able to retrieve a ticket, and it has actually stored that ticket in randomuser.c cache. So we now have a ticket, and with that ticket we can reuse that. We can actually use that to connect to the host using several tools actually. For example, well, the first thing I have to do is create an environment variable containing that user or that file name, so that the tools, if I specify Kerberos authentication, knows to use that Ccache file. So this is something that is built into the tools. Impacket and CrackMapExec are the two toolkits that I will show you in a minute. This is built in there. It's actually a common name in a Kerberos environment. So it's built on DNS. So for example, if you want to be sure that the demo will work, or that your hack will work, you might want to do something like this, and then of course make no typos like I did. If there is no IP address resolved right here, then it will certainly not work. It's built on DNS. What I actually did to make this work is also not uninteresting. In the settings, I have overwritten the standard DNS server and pointed it to the domain controller. Most domain controllers are actually DNS servers. This is important. A separate way of doing it is by manually specifying in the host file like this which IP address to which name. All the same result, but it does allow me to use something like an SMB client, which is built into Impacket as well. But this SMB client has support for Kerberos authentication. Let me show you the options. -K uses Kerberos authentication, and it automatically grabs the credentials from the cache file, Ccache file that is configured right here. So let's specify it, K, and then of course I need to specify the machine that I want to connect to, like this. Worked. So list shares, list the shares, use for example this share, and then as you can see we have full access as administrator, or not as administrator but as system, because we are using a machine account, so we are system to access whatever we want. Of course, SMB client, that's not so heavy. Something that is a little bit better, or maybe speaks more to the imagination, would be PSExec. But we have a problem. The PSExec from Impacket, or even the one from Metasploit as well, is actually recognized by the antivirus that is built default into Windows. Let me show you. As you can see, an executable is created, an executable is being uploaded, and then the built-in antivirus in Windows Server 2022 detects it and throws out a message. Right. As you can see right here, it's exactly that executable. So PSExec is actually not usable in here. There's of course another way, for example ATExec, which abuses the fact that you can remotely create scheduled tasks. So this is actually creating a scheduled task. Let me see. Yeah, we have to specify the command that you want to execute. For example, who am I? This is the task that is created as a system, and then it runs, and then after a couple of seconds we get the results of the run back, for example. So this is code execution on the remote system. Well, maybe it's time for CrackMap now to make it fully available. So this one, again, we need the host name and not the IP address. We already know that this should work, right? So we have an option Kerberos here as well, and if I just specify it, It's already done. It says random user because that is what the username that is specified in the ticket, but it's not really used because, well, as you can see, we are pwned, and whatever we run, for example, perform a SAM dump, should work. We have a full SAM dump. Okay, interesting. And this is a domain controller. So since it is a domain controller, we can actually perform a full DC sync attack is actually the correct term, to make a backup of every single domain object, and there are a lot of them, including their hashes. Right. So we have the full domain takeover in this case. Okay, that's it for me. Thank you for listening, and I hope you keep learning. Right.